Welcome to The Explainer. Today, we're diving into something that honestly feels a little bit like magic. I mean, what if we could actually talk to animals? It's a wild thought, right? Well, we're going to start this journey close to home with our fluffiest, furry friends. Meet Cash. He's a very good boy, and he's got this 130-button communication board. His owner, Christina, says they actually use these buttons to, well, converse. Get this, Cash seemingly told her he felt sad and then sick, literally right before throwing up on the couch. I mean, when you hear that, it really sounds like he's truly understanding his own internal emotional state, doesn't it? But, man, this brings up such a fascinating question. Is Cash really processing his complex feelings using human words? Or is this just adorable, incredibly sophisticated begging? Truth be told, researchers are actually pretty split on what these button boards really prove. Because the reality is, if we're ever going to truly claim we've cracked cross-species communication, we can't just expect to teach dogs English. That's a one-way street. We need to decode their native sounds. We need to figure out how to speak their language. And you know what? That is exactly where artificial intelligence steps in. Section 1. AI as a Rosetta Stone. So right now, scientists are literally trying to build an automated animal translator, and they're using the exact same technology that powers those modern chatbots we all use. The secret weapon here, it's an AI architecture known as the transformer. Think of a transformer as something that takes massive reams of data and plots it out like a giant galaxy of stars. In this multidimensional geometric space, the actual physical distance between words is everything. So the distance between queen and woman compared to princess and girl, that physical distance holds their actual relational meaning. The AI understands context based entirely on math. And this brings us to a massive, absolute game changer of an AI superpower. When you map out different human languages, even languages that seem completely different like English and Urdu, they actually form surprisingly similar geometric shapes. So what does that mean for us? It means you can literally just transpose one map right over the other to seamlessly translate between them. It acts exactly like a digital Rosetta Stone. Now, organizations like the Earth Species Project are taking this hidden mathematical structure and actually applying it to the animal kingdom. Step 1, they record just massive amounts of data. Audio, video, motion, the whole shebang. Step 2, they have to solve what researchers call the cocktail party problem. Basically, that means trying to isolate one single animal's voice out of all that crazy background noise. Then, once the AI learns that individual's specific syntax, it moves to step 4, trying to predict the very next sound. Ezra Raskin from the Earth Species Project sums it up so perfectly. He says, they are essentially building predictive text, but for birds. I mean, it sounds incredibly cute and super sci-fi, right? And the crazy part is, in tests, AI can already continue a bird's song so seamlessly that our human ears literally cannot tell when it switches over to being fake. But we gotta pump the brakes for a second, because taking this very human-centric AI and applying it to the wild, it comes with a massive, glaring limitation. Section 2. The human language fallacy. Okay, so translating English to Urdu is one thing, but translating English to whale, that's a whole different ballgame. We really have to ask ourselves, will a wild animal's worldview actually map on to our very complex human language shapes? We tend to just assume animals care about the same things we do, but do the things they vocalize about actually fit neatly onto those geometric language maps we just talked about? To answer that, let's take a trip to a beach in California with biologist Caroline Casey and her elephant seals. There is such a sharp contrast here between our fancy human expectations and the raw reality of the wild. See, while we're out there looking for complex grammar or abstract thought, male elephant seals basically just spend their entire mating season making these wild, rhythmic drumming noises. And as it turns out, after years of doing these playback experiments, Dr. Casey discovered something pretty funny. These males are essentially just announcing their own names over and over again. As she puts it, they come in and they're like, "Jim here," and honestly, that's the only thing they say. So the absolutely crucial takeaway here is that a seal is not out there speaking in verbs and nouns. The entire meaning of their call relies completely on personal, biological context. If a seal hears the name Bob, well, that only means something if Bob has actually beaten him up previously. So an automated AI Rosetta Stone all by itself simply won't work here. Why? Because it completely lacks that physical, real-world context. Section 3. The power of observation. And this perfectly highlights why we can't just press some magic AI button and expect to talk to animals. We have to contrast that automated machine learning with direct, boots-on-the-ground human observation. Take Dr. Lucy King's research over in Kenya. She kept hearing this indigenous folklore about how elephants are absolutely terrified of bees. So she decided to actively observe them. She hit a speaker, played the sound of angry, disturbed bees, and just watched. The elephants fled, they shook their heads, and they aggressively dusted themselves to knock these invisible bees out of the air. By recording all of this, she managed to isolate this one specific low-frequency sound. She called it the bee rumble. And here's the kicker. When she played just that rumble back to a herd of unknowing elephants, they reacted the exact same way. It gets even more fascinating. By patiently watching them, Dr. King basically proved that elephants have context-specific words. Let's break it down. When they hear the sound of bees, they run away, shake their heads, and use that bee rumble. But when researchers played the sound of Sambaru warriors, the elephants ran silently, no dusting. And they used a completely different, much quieter rumble, essentially a specific word for scary human. They literally changed their physical reaction and their vocabulary based entirely on the specific threat they're facing. And here is why all of this matters to us right now. Because human scientists put in that warm, observational fieldwork to decode the bee rumble, they were actually able to invent this brilliantly simple solution: protective beehive fences. It works like this. By stringing up actual hives around a farmer's crops, if an elephant comes along and disturbs the wire, the bees are released. It safely sends the elephants on their way, completely preventing what could otherwise be deadly human-elephant conflicts. That is just incredible. Section 4. The ethics of listening. Okay, so let's play devil's advocate for a second. Let's assume AI does eventually crack these incredibly complex codes. Does that automatically mean we are actually ready to speak back to them? We really need to talk about the massive, far-reaching ethical risks here. For example, humpback whales adopt each other's songs, right? And they broadcast them for thousands of miles across the ocean. So think about it. If we carelessly drop some AI-generated synthetic whale song into the water just to see what happens, we could literally overwrite and destroy a 34-million-year-old wisdom tradition. We could unknowingly impact their navigation, their behavior, and honestly, entire ecosystems. The stakes here are just incredibly high. As this AI technology continues to rapidly advance, experts are sounding the alarm that we must establish some very strict boundaries. As Raskin even suggests that we might literally need a Geneva Convention for cross-species communication. And honestly, he's right. We need something like that to prevent us from accidentally causing total ecological chaos. So I want to leave you with this final, hopefully provocative thought. AI might very soon give us this ultimate magical superpower to finally decode the animal kingdom. But if our real ultimate goal is to actually improve our relationship with the natural world, well, when the animals finally speak, are we humans truly ready to just shut up and listen? Thanks so much for joining me on this explainer today. I really hope it sparked your curiosity, and I will see you on the next one.